There we go. Thank you. So my name is Vlad Jovanovic. I'm a program manager at Microsoft, and I'm joined by Simon Davies. And for the next 75 minutes, we're going to talk about Azure Resource Manager. The title says how to make production deployments safe and repeatable. And we're really going to talk about how to make it declarative, how to use infrastructure as code, and really help you move from the ways that you deploy your applications today and how to really start in Azure. How many people here are really familiar with Azure, really understand ARM, are pretty much experts in ARM templates? Experts in ARM templates, lots of hands going down. For the experts, we have a tips and tricks section tomorrow at 4 by Brian and Gaurav that'll go into a lot of detail. In this session here, for the people who've used ARM before and are familiar, bear with us for the first bit of the session. We're going to try to get through sort of what is ARM and really start from the beginning, kind of get people from 0 to 60, and then cover some of the innovations that we're working on and some of the things that we're really trying to go and really make things even easier for you. So we're going to do an overview. We're going to talk about sort of what it means to be declarative, what this template language looks like. Simon will cover a lot of those declarative options. He'll chat about some of the new template deployment options. And then we'll talk about how we're really investing in sort of the future ARM scenarios, really trying to make even more services sort of feel like software as a service for you, and talk about some of the future directions. So looking forward to covering that over the next 75 minutes. And if you are an expert and you happen to get in this room, there's you won't hurt our feelings if you sneak out and cover tomorrow's session instead. So if you stay, that's great too. So what is Azure Resource Manager? Essentially, Azure Resource Manager is a global service that's running in every Azure region in public Azure. It's running in Azure Stack. It runs in our sovereign national clouds. And it's a service that comprises a lot of different features that customers can do to really provision these things called resource providers. It is this gateway that you access. It is this URL that's completely extensible based on these resource providers that have been built sometimes by internal teams, sometimes by external teams. And all of these different resource providers abide by this thing called a resource provider contract. So there is a contract that these resource providers must abide by, how to perform a particular get, how to perform a put and a patch, and all of the different HTTP verbs that customers could use. And we've done that so that interacting with all of these different resources that you could deploy in Azure is very consistent and is very repeatable. And you understand if you've used one service that you'll likely be able to use another service, that you can apply tags to these different services. At Microsoft, I sometimes feel like a police officer. I essentially go around and sort of almost KPI teams to sort of death in some cases to try to make sure that they do the right consistent things. And a lot of times I use evidence that you guys, our customers, give me on things that maybe aren't as consistent as could be, or things that you wish were consistent but actually aren't because of some of the implementation details. And if you ever find those, definitely bring those forward, and I can sort of help you. That will help me bring sort of a witness impact statement back to Redmond and make sure that we can make all of these resource providers as consistent as possible. Now, above this ARM service, you obviously have lots of different clients that you can access this ARM resource provider, these resource providers, these services. Sometimes these clients are our own portal, going to portal.azure.com, using any of our CLI tools or any of our third-party tools. Sometimes you don't even know that they're going to ARM, but they're going through ARM, going through a subscription, going through a particular resource group, and going through those. So it goes through this particular endpoint. Now, ARM exposes this all as sort of raw HTTP that you can access. And some customers choose to go directly against that HTTPS point with their own client, with their own code that they write. And a lot of times, that's if you've been in Azure sort of circle for a while, that's what a lot of customers did. We now have a lot of different management SDKs that you can leverage. So if you're using Java, there's a Java SDK or a .NET SDK or a Ruby or PHP that stays on that treadmill and builds sort of great SDKs that are great for those different languages and work well with those languages. And you don't have to understand the sort of raw HTTP and looking at all of the different schemas of different resource providers. So you think of ARM, that's what ARM does, and essentially since I started just about 6 minutes ago, ARM has served thousands and thousands of requests of different, could be just serving data for a customer subscription, could be doing a particular deployment. Right now there's around 3 billion transactions per day going through ARM across all of the different regions, across all of the different instances in ARM. And this is managed by the ARM team, and all of the resource providers are essentially different deployable units that are owned by different teams as they sort of own those services. So that's kind of what is ARM sort of all up. Now, let's think about the life of an ARM request. Kind of put yourself in the shoes of a particular HTTP request that's going to ARM. So let's imagine we're sitting here in Orlando and we're going to do a get on a virtual machine in a particular subscription in a particular resource group, but that particular subscription and resource group and that VM is actually in a different region. So when we use that particular HTTP operation from here, we'll get traffic managed once we hit management.azure.com to a local data center closest to this Orlando area, something along the East Coast. And then after that gets transferred to that front door instance, it has to make a bunch of decisions on that request. It processes the request. It looks at, is that subscription valid? Is that resource group valid? Does that resource provider even exist in that realm of in this case, the public Azure instance? Is it a real resource provider? Is it a real type that resource provider exposes? It looks at the identity of that the token that operation comes with. Does that user have access to that subscription in that resource group? It checks to see if there's different feature that is enabled. So different resource providers can have features that are either exposed or not exposed. Is that subscription exposed for that feature? All of these operations are things that the ARM processing engine does. And if any of these sort of fail, or we don't authenticate, or it's the wrong URL, wrong RP, essentially fails and gives the user a 404, the appropriate response. Now, if it does succeed and those things all check out, then it actually sends it to the resource provider. In this case, it sends it to the resource provider based on the resource provider's registration with ARM. And there's really two types of resource provider registrations. There can be something called a global resource provider or regional, in which case we actually have to route it to the endpoint that's responsible for virtual machines in the location that we've accessed. In this case, it would forward that request to the resource provider for compute in the Australia, whatever region it was in Australia. And then the response would come from the resource provider, it would flow through the ARM front door, and it would send it back to the response. So that's kind of the life of a simple request. Activity logs are sort of sent to the activity log for any sort of non-getter operation so that you can see the tracking of that. They can also optionally be sent to Event Hub. So that's kind of the life of an ARM request, right? That's that happens 3 billion times per day. Now let's think about the life of a request that is a little bit more complex. So in this case, you're actually doing an operation that has a ton of operations around it. You're not just doing sort of a simple get on one resource, but you're actually doing a delete on a resource group. And let's say there's 100 resources in that resource group, and it is sort of in many regions. Or let's say we're doing a template deployment that's going to create a bunch of other resources. In this case, a lot of this first part is very, very similar, but then it actually doesn't send it directly to the resource provider. It sends it to a job engine. And the job engine processes this and does all of the appropriate retry on your behalf. So in this case, you didn't have to go and delete every single one of these 100 resources. You just deleted the resource group, and ARM did all of the retrying and all of the right logic and sent it to all the different resource providers, collected all of the results, and then sort of passed that back on to the user. So this is sort of the life of a little bit more complicated request. So as you're thinking about using ARM, these are some of the things that you can think about as data is flowing through the system. Where you're in, what region you're in, depends on sort of the first instance that you hit in ARM. But then after that, it sort of gets distributed to the region of the resource that you're really working with. So if you're working with resources that are in The West US region, a lot of times you'll be hitting resource providers there, but going through a front door here. So that's kind of give you an idea of sort of just the data flow through the system. So as you think about using ARM, either through REST directly or the SDK layer, it's important to understand some of the things that SDKs are doing for you, and some of the things that you may need to do in your own application of leveraging REST if you're not going to use these SDKs. Some of these long-running operations and different paging or retries, the SDK layer handles a lot of those. Some of the connection management is handled by the SDKs. And then different strongly typed resources are created through these REST APIs into the SDKs, so you can use these different objects like a virtual machine as a strongly typed resource. Different things like authentication, token refreshes. All these things are supported by the SDKs. So if you're going to use an approach today starting, definitely encourage you to look at some of these SDKs and not leverage sort of the raw REST scenarios. And all of our SDKs are generated over our different swaggers that the resource providers create. So that's some of the things to get started on just using ARM from sort of being an API gateway, if you will, of everything through what we call the control plane. Control plane, the creating of a resource, deleting of a resource, changing the SKU of a resource are classically these control plane operations. Versus data plane, when we say data plane, we really mean the VM communicating on to different VMs on a virtual network, or RDPing to a VM, or uploading data to a blob in a storage account. Those are sort of data plane operations, where control plane operations are creating the storage account, deleting the storage account, creating the VM, deleting the VM. So as we think about having these immutable and declarative scenarios, we're really going to talk about the things that you have to think about in your approach to be declarative and immutable. And clearly there is this thing, there's the resource. Could be a storage account, could be a Cosmos database, could be a machine learning account, could be a cognitive service, a data factory, hundreds of services. I think there's almost 350 different resources that you can sort of create in a particular resource group. And often you'll have more than just these resources. And you can do a lot of that through a template, all of these things through a template, to a resource group, to a set of resources. Simon will talk about subscription-based deployments. But there's 3 scenarios that you need to think about as to how you will be declarative and immutable for these scenarios. And this is where it classically sort of depends. The first area is sort of underneath a resource, or sort of the data plane of a resource, or sometimes I call it the last mile of a resource. So if you're creating a VM, how do you configure all of the in-guest configurations? If that VM needs to be part of a domain controller, needs to be part of a domain scenario, how is that virtual machine going to be joined to a domain? Is it going to be a custom script extension? Is it going to be a DSC extension? What's going to do that in-guest configuration? If an ARM template is deploying the virtual machine, maybe you could use a custom script or a DSC extension as part of the template to deploy those things in-guest. Or will you leverage another approach for in-guest because you're already using Puppet and Chef? What's that sort of resources last mile? And this is where it really depends on the resources that you're using. If you're using containers, maybe there's a Helm script. Maybe there's a number of things that you're going to do within the data plane of that particular resource that you've created. And if you're using some sort of SaaS that doesn't have a lot of in-guest scenarios, then a lot of times everything is in that particular resource. There's very little to configure on a virtual network, let's say, or in sort of data plane. Everything's really exposed through this control plane in that SDN layer for network scenarios. So that's one of the scenarios that you've got to think about. The second area that we've definitely seen a lot of customers think about as they adopt Azure and they adopt different clouds is, how do all those resources get created that are sort of not in Azure, but are related to this scenario? You've got to configure a Datadog service or a Cloudflare DNS scenario or some other thing that's sort of not in Azure. How does that get to be immutable and declarative? And how does that get exposed as infrastructure as code? And there's where we have a private preview of a Terraform OS SRP that Simon will talk about. And then sort of above these resources are all the different decisions you have to think about of of what's going to orchestrate across all of these. How are you going to do different service requests? What's the CI/CD sort of story for storing these templates and all of these in-guest configurations? What's that automation layer look like? How are you going to do this across different environments for your app or things above a subscription? So these are some of the considerations for for what your approach to being declarative is. Are you in multi-cloud scenarios where you actually want to orchestrate across AWS, you want to deploy across Azure and an Azure stack? Terraform is a pretty good option in that sort of scenario. How are you going to be leveraging IaaS versus containers? There's great sessions later this week on some of the automation and function capabilities to extend what templates can do. And then what's your own team's background and familiarity with these different technologies? Often does influence the path that you take to leveraging Azure and leveraging its scenarios in these hybrid cases as you're potentially lifting and shifting, and you have VMs that today have no way to be configured in those ways because people are still doing things sort of as pets. So as you think about that approach, these are some of the areas to think about. And this is definitely where we feel like templates solve a large part of this problem. And it depends on some of these other scenarios. So think about that as we think about all of the different ways to be declarative and immutable. And I think Simon's mic can be enabled from here. Simon will cover some of the deployment resource definitions and give us some demos, and I'll be back.
So I didn't turn around when Vlad asked the question. Hello, everyone. I'm Simon. How many people have written or used an ARM template? Oh, wow. OK, we'll probably go through this quite quickly. I just wanted to sort of review, level set what a deployment is in sort of two halves. One is how do you define one, and the other is what happens when you actually do the deployment. So the ARM template language is a JSON formatted DSL, has inputs and outputs. So I can create a template, it has parameters. I might do that because I want to reuse the thing across different environments or whatever. It might have some outputs. It might, I don't know, create a virtual machine with an IP address, and I need the IP address to be given to me afterwards because I'm going to configure some DNS or something along those lines. It obviously declares the resources you want us to create and what properties you want setting on those things. But it doesn't do it in a way that tells us how to do it. You sort of create this linear set of resources and define what the dependencies and references between them are. So a virtual machine might reference a NIC, for example. Or you might make a virtual machine dependent on a network security group. And you do that in a declarative form. Templates also have language expressions, functions, if you like, that you can use at runtime to derive values. So you might want to know, a simple example might be, what's the location of the resource group I've been deployed into, so that you can set the location for all the resources to be the same as the resource group. It's a common pattern, but you might not want to do that. And then finally, deployment is a resource. And because a template allows you to define resources, then you can nest a deployment inside a template. And there's lots of reasons why you might want to do that. One of those would probably be reuse. And Brian Guerrero will probably talk a lot about various scenarios around that tomorrow. So that's the definition of a deployment. The next part is what happens when you actually deploy it. Now, a deploy is just a put on a resource, on a deployment type. So it's, as I say, just another resource. And the first thing that happens is we pass that request. Is it well-formed JSON? Is it a valid template? And once we've passed it, we create a resource graph. We figure out what the order of creation of the resources and how the resources depend upon each other. We then do some validation. We validate whether the contents of the template are correct. Do the resources that you're trying to create actually exist? Do they exist in the location you're trying to create them? In that validation, not only does ARM do validation, but the resource providers can also validate. So for example, when you create a virtual machine, CRP can validate whether or not you have enough quota to successfully deploy. And this allows us to, in many cases, stop you from doing deployments that would subsequently fail an hour and a half into the deployment. But some validation can't be done at that time. It has to be deferred till runtime. So think of a scenario where the input to one resource is dependent on the output from another resource, and that output is computed at runtime. Then obviously we can't validate that until such time as the output is actually available. And all this validation capability is exposed through an API, which is exposed through CLI and PowerShell, which means that you can explicitly call and validate your deployments before you submit them. And this is useful both at runtime, but also obviously when you're authoring templates. And then finally, we'll take that graph and execute it. So we'll parallelize all the updates, the creates and updates as much as we can. We'll automatically retry on failures. If a RP sends a 429 response back, we'll retry. Lots of times, if you imagine that you're creating a lot of resources in parallel and you end up calling the same RP maybe 10 times concurrently, those RPs can end up saying, no, stop, I can't do this all at once. Please call me back. It takes care of all those issues for you. As I mentioned, the deployment is a resource, but what happens with the deployment ultimately is that we will drive it to a terminal status. That terminal status is either it succeeds, it fails, or it was cancelled. That's it. There are 3 terminal statuses for a deployment. It will be one of those. Now, the individual resources themselves can have their own status, but the deployment itself is always going to end up as one of those 3. So pictorially, that looks something like this for maybe an ARM template that creates a virtual machine with a diagnostic storage account and a public IP address and an NSG. You might have a scenario where the virtual machine has a reference to the diagnostic storage account. It might also have a reference to the NIC. The virtual network might have a reference to the network security group. The NIC references the public IP address, and perhaps the NIC explicitly depends upon the virtual network. And what will happen at runtime is we'll explode that template into a graph. You can see the 3 resources at the top, the public IP address, the virtual network, the diagnostic storage account will all get created in parallel. The network security group gets created once the NIC is created. The NIC will get created once the public IP is created in the virtual network, and the VM ultimately gets created when the diagnostic storage account and the virtual machine is created. Now, one of the things you might want to do in this scenario is there's a hole here potentially whereby you can deploy the virtual machine before the NSG has been created and let traffic into your network that you didn't necessarily want to do, and that might be a case where you put in an explicit dependency between those resources to ensure that they get created in the order that you want. So in order to create these things, we have support in Visual Studio Code, Visual Studio, and in the portal. Inside of Visual Studio Code and the portal, there's also links out to the Quick Starts template library. There's in the region of 700 templates in that library. You can take them, use them as they exist. You can learn from them. You can modify them and use them. You can contribute to that library. Now, Vlad mentioned at the start tools like Terraform. We don't really have a strong opinion that you should use ARM templates. If Terraform is a tool that makes sense for you, you should use that. We have support for Terraform inside of Cloud Shell. We have Terraform already built in. we work on a provider for Terraform that tries to provide really good Terraform implementation of all the Azure resources. And we're also working on Terraform modules for the Terraform module registry. Same thing is true if you sort of come at this more from a configuration management background and maybe you use Chef. Chef has a set of support for at least some Azure resources, mainly virtual machine based. Again, Chef is in the Cloud Shell. There's reasonably good support also in VS Code for Chef. Same again with Ansible. Ansible's in the Cloud Shell. And there's good support for Ansible in VS Code. In fact, if you install the correct extensions in VS Code for Ansible, you can literally right-click on an Ansible playbook and select Run in Cloud Shell, and the extension will deploy it and run it inside the Azure Cloud Shell, actually hosted inside of Visual Studio Code. So that's a little bit of positioning and background. I'll just cover some things that we've done over the last few months in terms of improvements, both the template capabilities, but also in terms of deployment capabilities. So first thing is subscription deployments. And up until this feature, the only way that you could deploy a template was under a resource group, in other words, a resource group scope. This means that templates were only good for creating resources inside of a resource group. If you wanted to create or manipulate resources that didn't live inside a resource group, then you have to do something else. So now we can do this subscription deployment. It means that you can do things like create RBAC, create roles, custom roles in a template, do subscription-based assignment, create policies, even create resource groups inside of a template. And that enables you to then build a scenario that might have the creation of a resource group. Maybe you create some policy and assign some policy. Maybe you assign some RBAC to that resource group. And then finally, because you can nest deployments and you can nest a deployment to a resource group inside of a subscription scoped template, you can then do a deployment to that resource group. So a bunch of things that would traditionally require you to write quite a lot of imperative code can now be done through this mechanism. There's a few little differences between resource group scope deployments and subscription scoped. We don't support complete mode. If you don't know what that is, don't worry. We have another new feature called on-error deployments I'll describe in a minute, but that only applies to resource group scope deployments. And then some functions like the resource group function don't really make sense inside a deployment that's done at subscription scope because there is no resource group. And we've exposed that capability through a couple of new commands in PowerShell and the CLI. So in the CLI, it's AZ deployment or AZ deployment create. Okay. Or new Azure RM deployment. So what I'm going to do is, if this machine is still working, do a very quick demo of this. There we go. So, as I say, the new command is AZ deployment create, in this case. And we need a template. And I can't actually remember what that template is called. Oh, there we go. So a template file, I'll show you what's in that template in a second. One of the things that we have to do with the subscription scope deployment is specify location. For a resource group scope deployment, all the metadata about the deployment is stored in the location where the resource group is. Subscription doesn't have that, so we have you tell us where you want us to store that data. So, and this will also be where it executes. So we'll put that in East US2 because that's pretty near. And we're going to set a parameter on this template, and it's going to be a resource group name, and we're going to call that something like that, and we'll start that off. And hopefully, if I've got that right, it'll actually start deploying. Yeah, there we go. Now, if you look inside the template, it's pretty much identical to existing templates. There is a schema for subscription scope deployments that's different than the schema for resource group scope. This really only drives the tooling. It doesn't have any fundamental impact on the execution. You see here I've got this resource group name parameter, and then here I'm using that to create a resource group. And then once I've created that resource group, I've got a deployment that's dependent on that resource group creation that's going to create a storage account inside of the resource group that we just created. One thing you can do with subscription-based deployments, I mentioned a minute ago this function where you might get the location from a resource group. For a resource group scope deployment, we make the location of the subscription deployment available on the deployment object, which is slightly different than what you would see with a normal deployment. And that's really it. There's really no difference other than the fact that obviously the resources that you create have to make sense in the scope that you're at. And you can see now I've created that resource group. I've created a storage account inside that resource group. If I come over here, we should see that that thing exists. And there is indeed a storage account inside of it. So that's quite a nice feature. This one is sort of a very small thing, but I think it enables a really interesting scenario. So the background to this is that one of the ARM template functions is list, what I call list star. If you're familiar with storage account, there's a list keys action on the storage account, on the storage RP. If you're familiar with AKS, you can do a list credentials on an AKS cluster. And the way this works in the template language is basically any action that's exposed by an RP type that begins list, we automatically map to inside the template language. Now, up until this new feature that I'll describe in a second, that would only work if that action did not take arguments. In other words, you could not specify arguments to that list function that were going to get passed to the RP. You think about listing account keys for a storage account, right? There's no arguments to that. It's just like, give me the keys, and you get a couple of keys back. But it turns out that storage and other RPs have functions that require arguments to return data. And in particular, storage has a couple of list functions, one called list account SAS and one called list storage SAS. And those things will give you a SAS key, a SAS token. But you couldn't call them from within a template. So what we've done is enabled the ability to pass data from the template into the RP in order to generate a response. So what that means is now that you can, for example, use this capability to stage nested deployment templates into a private storage container. And then from inside of the template generate a SAS token for ARM to use to access that thing, and you don't have to make them public, or you don't have to generate a SAS token outside and pass it in. There are some other examples where it's useful. There's, I think Linux Diagnostics requires a SAS token. Linux Diagnostics extension requires you to provide a SAS token to it for it to work, in which case it couldn't work in a template, and now it can. And you can see at the bottom here, unfortunately, it seems to get squashed a bit on my screen, there's a variable defined here which contains the body that's going to get posted to the RP, and over here we're just passing that variable content as an extra parameter in the function. So the third thing then is improving the way that we do error handling. And one of the big pieces of feedback we get from many customers is, I want you to roll back my changes if something goes wrong. Now, this is really easy to think about as a requirement, but quite difficult for us to implement, because some of the state transitions that happen in resources really can't be rolled back, plus it's not a transactional system. So the way that we've implemented this feature is by enabling you to specify when you do a deployment that you want to have a previous successful deployment deployed in the event of a failure. So basically, if your deployment fails, we will automatically run a previous deployment that you specify. Either you specify it by name, by ID, or you specify it by saying just do the last successful one. And we'll automatically use the same mode that that thing was done in, and we'll use the same parameters. So you don't have to pass anything other than just use that one. That capability is only allowed on the root deployment. You can imagine that gets quite complicated if we try and do that with nested deployments. And that capability has been exposed as a flag on the AZ group deployment create and new Azure RM deployment resource group deployment commands. So we'll try and do a very quick demo of that. And in fact, the scenario that is probably appealing to a lot of folks is that if you create let's say you create a resource group and then you do a deployment to that resource group of an empty template, and you do that deployment in complete mode, you can now use that deployment as an on-error deployment, which will have the effect of deleting all the resources that got created in the event of an error. In other words, it will roll everything back to being empty again. And that's probably really quite useful at least in a dev test scenario. And in fact, many customers use deploying an empty template as a shorthand for delete all the resources in a resource group. Otherwise, you have to write a bunch of code to enumerate all the resources and then independently call each one. So I think rather than run that in the interest of time, I'll quickly show you the code. It's pretty straightforward. Here's my empty template. I create my resource group. I run the deployment. I mark it as mode complete. And then let's say I run this template, which is going to fail intentionally. When I run that, if I was running in using the AZ CLI, I'd just do minus rollback on error. If the empty template was the last one, that thing would get run and everything would get deleted. So it's an interesting feature, but you need to be really careful with it because not every resource is going to be able to behave in the way you want it to or you're expected to. For example, imagine that you have a virtual machine and you've installed an extension on it, and that extension has changed the state of the VM in some way. Rolling back to remove the extension is not going to remove the effects that that extension had necessarily. For some of them, it will clean up after itself. But if you took like a custom script extension, there is no capability to reverse the effects of that. So you need to think very carefully about how you use this feature. There are other scenarios with some RPs where those RPs don't necessarily behave in the way you expect them to do when you reset properties. Some properties are immutable. So there are some things to think about. So the final feature, very quickly, is having the ability to create functions in templates. Now, this isn't the ability to embed custom code inside of a template. It's really a shorthand for a chain of ARM template functions. It's really aimed at allowing you to be less repetitive in the way that you write templates, and also to make it easier to understand and easier to maintain templates. And we see on there's a bunch of restrictions that we have. The intent here is to produce a feature that has a very small scope and then get some feedback from you and understand how we need to enhance that feature. So we want to make this better, but we wanted to take a small step in creating it. So those things look something like this. At the top there, you can see there's a new property in a template called functions. It's an array of objects. Inside the object, there is a property called namespace. So functions have to have namespaces. And then inside of that, there's some members. Each member is then a function. The function takes in parameters and produces output. And you can see in this instance, this function is taking a name prefix and generating a unique string and concatenating it to that prefix and returning it. And then down at the bottom, it's using that function to populate the name property of a storage resource. And you can see that it's using a namespace.function syntax. So here, contoso.uniquename. So that literally is everything about functions. As I say, we'd love your feedback about this feature and how it works for you. So the last thing then is we released a feature a few months ago in private preview to try and address some feedback we'd had about ARM template language and its scope. So if you think about it today, you can only use the ARM template language to manipulate resources in Azure. But some customers want to be able to use that same language to manipulate resources outside of Azure. So what we've created then is a resource provider that you can think of it as a wrapper around Terraform. It enables you to make ARM resource calls and have those resource calls invoke Terraform providers. Now that means that from the outside, these things just look like any other ARM resource. You're still creating still doing a put on a resource provider. It's still a JSON formatted thing, and we'll do the translation from JSON into, well, actually don't translate into HCL, but you can think of it conceptually as translated into HCL and invoke Terraform to deploy the resource. And the idea here is that we can reach outside of Azure, so you can manipulate resources outside, but also it's handy for control planes that live inside of Azure that don't abide by the ARM RPC contract. And the most obvious example of that is Kubernetes. So if you create an AKS cluster and you create that in an ARM template, then how do you then go on to configure pods and services and so on top of that Kubernetes cluster? Well, now using this RP, you can do it because we can leverage the Kubernetes support in Terraform. And now you can write a template that not only creates an AKS cluster, but also creates pods and services and so on. But equally, you can go outside, and if you're using Datadog for monitoring, if you're using Cloudflare for any of their network services, you can interact with those providers as well. So the intent here is to basically try and cover as many of the official Terraform providers as makes sense. Some of them don't make sense because they're client-side things. But all the ones that make sense in a server-side context, we will try and enable. And again, we'd love you to give us feedback on the scenarios you have so we understand which ones we should prioritize enabling. You can sign up for the preview at that link there. It is a private preview, but I'll enable everybody who signs up. So if you want to go try it out, that'd be great. Give us some feedback. That'd be fantastic. I'll just do a very quick example of this. I'm not going to deploy it because it's going to take a little while, but I'll just show you what it looks like. The example I'm using is using a Datadog provider. And the scenario is you've created a virtual machine, just like you create any other virtual machine in ARM. And then you've installed Datadog's extension on that virtual machine. So here's the Datadog agent being installed as a VM extension. And then what you're able to do now using this new provider is to go and configure Datadog's SaaS service to actually consume the data that's coming out of your virtual machine. And in this case, we're doing two things. First of all, we're registering our app key and API key for Datadog inside of Azure using this provider's registration type. And then we're going to the Datadog resource in Terraform and using the time board and configuring effectively a chart, in a graph inside of Datadog, which shows CPU usage and system CPU usage and disk read percentage and so on. And what you end up with is a deployed VM inside of Azure, but also you end up with, in this case, that specific dashboard. So now you're deploying your resources in Azure, but also deploying this associated set of resources that live in the outside world. So hopefully you'll find that reasonably useful. If you're interested, please sign up. And like I say, definitely interested in feedback on that. All right, so I'll hand back to Vlad. Thanks a lot.
Thanks, Simon. So there's a number of sessions on some of the governance features that are being added to the Azure platform. I wanted to cover just a few here so that you know about the different sessions. As you think about the governance scenarios, think about having to manage tens of subscriptions, tens of different teams, really doing things at scale where we are with cloud adoption now, you're at a point where you could really give teams sort of rails to stand on and really enforce compliance, enforce your different corporate policies around encryption, around open ports, around sort of known bad vectors. How do you make sure that your engineering teams don't run around with scissors and sort of aren't carrying them the right way? So there's a number of features that we've added to make it easier to do policy-based management as the time of resources are being created, or later as you come up with new initiatives or new ideas that you want to lock down. Obviously, being able to visualize cost across these scenarios is an important scenario, but then also the ability to search across all your resources very quickly. We talked about ARM having to fan out to resource providers. That's because ARM doesn't cache the whole set of properties for these resources. They're essentially, you can think of ARM almost stateless. There's a cache for certain resources and things like deployments and tags and those sort of things, but a lot of the other property, like is the VM running or not, is all of those things come from the resource providers. Resource Graph is a feature that is in preview that we talked about at Ignite, and there's going to be another session tomorrow by Tigran and Liz. We'll go into detail on how you can use this resource graph for all of the scenarios today where you may be collecting data, harvesting it from ARM, storing it in your own system so that you can leverage it. A lot of those could be you could leverage or sort of simplify all of those just by using Graph, because that data is kept up to date to the minute, and you don't have to sort of work around the different ARM throttling limits and throttling sort of rules until you run out of quota. Today we have a policy around you can do up to 2,000 puts and almost 15,000 reads or sort of gets for APIs across all resource providers. So you can think of using Graph as ways where you can allow your sort of important deployments and puts to be successful, and use Graph for the things where you're okay with a minute old data. And then for teams who are using, who have lots of teams leveraging their services and have more and more teams leveraging services, and you want to really sort of componentize and standardize on a set of things that you want every team to follow, and you want to really cookie cutter that scope, that set. That's what we've announced in Corey's session, and then a little bit more in Jeremy's session, and yesterday Joseph Chan's session on our Blueprint service. And there's a session tomorrow at 4 that's going to go into more detail there. And just specifically on Graph, this is where you can really explore your resources. The policy team is leveraging Graph so that as you come up with a new policy, you can easily do a what if to understand which resources are going to be impacted if you put that policy in place. How do you do some of those what ifs? How do you understand the impact of making some of these changes? And how do you do it really quickly without, again, having to scan all of your resources and try to figure those out? So a really cool feature that we announced here at Build. And then just a few months ago, we GA'd a new feature above a subscription called a management group. And a management group allows you to set up a hierarchy of subscriptions, and a subscription can only be in one management group, and then you can target different RBAC assignments, different user role assignments at a management group that inherent down through the subscription hierarchy. You can also target policies at these, and you can really think of all of the other services in Azure, like Security Center, different cost scenarios, leveraging these management groups for their different views. So you can sort of share these hierarchies. A lot of times people are looking at having roots as around production and non-production so that they can apply policies to these. And sometimes we see teams looking at team-focused ones, really this org, then different divisions, and then having production versus non-production subscriptions in those since policies are different. The other big feature that we're announcing, there's a public blog on it today, and then another session on it on Friday by David and Gaurav, is taking all of these great templates that you do for deploying services into one region, but actually being able to take these together and have a sequence to deploy it across many regions. So if you have a service that, like a lot of Microsoft services, as you know, with ARM, where they're deployed across many regions, how do you take those individual regional deployments, and how do you then roll these out across many regions in a way that gives you the control that you need, and the safety you need, and the right health checks, and the right time in between these different stages? If you think about the diagram that Simon showed, where ARM shows a particular graph and executes that graph essentially as fast as humanly possible. It'll just pound those RPs until that template either fails or becomes true, or you cancel it. And it'll only do that for 7 days, and then essentially gives up, or if you cancel it sooner. This now allows you to sort of take a spot and actually pause, and actually wait, and actually do something that you may need to do a health check before it goes on to the next one. So the Friday session has a few demos and more detail on how you can sign up for this preview if you have services that sort of fit that scenario. Sort of the next part that we want to talk about is really how we're extending Azure. And this is probably one of the sort of most exciting areas is sort of you as customers, you have Azure to sort of run the infrastructure, run the hosts, and run some of these things that you have to run. But now we're continually looking at how to allow ISVs, how to allow all the other SaaS or all the other software that you use and consume from different ISVs. How can these essentially show up in Azure as sort of mini SaaSes or things that you can just leverage in and not be completely responsible for maintaining. So if you think of ARM as really the construct as to how sort of things can be produced and things can be consumed. If you think of a sort of customer on one side and sort of an ISV partner or sort of a creator of software on the other, I wanted to sort of contrast these. So today we have this quick start that Simon talks about with 600, 700 different templates. Today partners can publish there, customers can publish there, customers consume these samples. Partners can consume them, but there's essentially no runtime connection, right? If you use the SharePoint template or the DataStax template, it's in your subscription and it's your problem to maintain and update and patch and everything, right? Man, that's IaaS. That's still a lot of work. Now, on the other end of the spectrum, we have resource providers that are sort of around 140 different resource providers that you can consume. And here, a customer, you can create a sort of a DataStax instance. You can create a Kubernetes cluster. You can create all these different SaaSes there. But the partner has to create those, maintain them, conform to this RPC. We did make one improvement sort of on the top of the quick start called the solution template. So in the marketplace, there's solution templates that partners have published. So there's now a DataStax solution template, a Cloudera, and there's sort of almost 200 different partners publishing solution templates where you get a great create experience. But again, there's sort of no long-time connection to the ISV, no sort of ongoing maintenance, no sort of work you can do or you can expect from those. And this is where we really sort of filled in this gap with this thing called a managed application that a partner produces, very similar to a solution template, but rather than the partner just handing it over to the customer to deploy and run, actually the partner continues having access to the scenario and continuing to can upgrade it, can improve it, can make it better, and things we're doing there. And then similarly, if you think about within an enterprise, you can expose the same thing through what we call a service catalog. So you can take a template and customize it for your particular enterprise. So if you took the SharePoint solution template from Azure, how do you customize that and make a service catalog for this so that you can actually ask the customers that are internally deploying within your enterprise which domains maybe that SharePoint should be deployed to, rather than creating a new domain in that particular template, and really make it custom specific to the enterprise. That's where we really think that sort of enterprise IT is almost like an ISV, a partner, a creator of these. So if you think about what's happening sort of in this sort of what inspired managed apps is really this ISV pattern, is that a piece of software was shipped to a customer and customer installed it, and Microsoft did this for many years, and the customer had a problem, they would call sort of this 1-800 number and essentially get support if they had it. Now, after a while, customers started running these in the cloud. Sometimes ISVs got direct access to what the customer deployed and had to solve it. And then partners started realizing, wow, I should build a multi-tenant SaaS for this and start offering as a SaaS in a public cloud. And sometimes multi-tenancy didn't work out for them, so they set up sort of individual customers per stamps, and sometimes those were really specific to customers. But customers often wanted to see it in their side so that they could customize it and specify it in the way that they wanted and make sure things were encrypted. They already had a big cloud spending contract, so they wanted to use their purchasing power to buy it. This is really where now it got really hard for partners. Most of the partners we talk to in ISV, from the ISV side, they have all of these. They still ship software for customers to run. They have a multi-tenant SaaS, plus they have per customer SaaS, and they were really looking for one model to really put all of their energy behind. And with a managed app, the customer deploys the resource into a managed app resource group, so they get really a first-class resource experience view for this new managed app. Maybe it's a managed instance of SharePoint. But then there is a separate sealed management resource group that only the partner has access to. It's in the customer subscription today because it's being billed to the customer. Individual usage is being exposed. But now the partner has access to it. They essentially see it from their tenant, which means their they're essentially providing a SaaS for you, or something that feels like a software as a service for you that you can sort of you can create and delete today, and we're adding more and more features to make it more customizable, and that's what we'll talk about on the next slide. So this is really sort of what we've been investing with managed apps and working with a lot of partners on. How do we make this self-contained, deployable, really so that you as the customer can expect a software as a service for these different pieces. We have a few new features to this so that a partner can actually expand what they can offer on these. And in yesterday, Jeremy Winter's session, Chef demoed a preview of their managed application, where not only do they have the ability to create these, or a customer to create them, but they also have other sort of actions that can be run on this managed app. So if you wanted to scale it up or stop it or do these other operations. And this is where we call it the mini RP, because it's sort of not as expensive and big as the resource provider to write, but it's sort of a mini one that gives you sort of first-class operations on that object, first-class visibility from different gets and different operations that you can do through this ARM control plane. We're also working on making policy supported for managed apps, making sure the tags can be written on things in managed apps because they're in a sealed resource group, they couldn't be tagged, and also being able to enable JIT so that there is a just-in-time enablement, so that if a partner has access to these, how do you actually give them only access through this just-in-time enablement? And we have that's in a limited preview. So that's some of the things that we were working on managed apps. And our request to you is, if you like these managed apps, please make sure you encourage the partners to build them, and definitely send them our way if they're not understanding what a managed app is or how to build one in Azure. But that's really what we're pushing on. And then on Service Catalog, this is a view in the portal where you can view the service catalogs that exist in my view. These are all of the service catalogs that are available. They're creatable by you as the enterprise. You can publish into a set of subscriptions, and then users in those subscriptions can create these, and they essentially form the exact same format where you as the enterprise provider get access to their resource group and can perform operations, maintenance operations, and they get a first-class resource that they can maintain and view, and obviously there's no sort of billing transactions there. So those are some of the future things that we're working on managed apps and service catalogs. Some of the other things we're looking at taking ARM, really the biggest, most important thing that we continue to invest in is really just our fundamentals. Running this service at 3 billion transactions per day and growing sort of almost growing quite quickly in a lot of our biggest regions. Not all regions are sort of symmetrically sort of growing linear. Some of our biggest customers are getting bigger. So really making sure that we can grow the service to support the scale, to support the performance. In many ways, we've been talking about this control plane almost becoming as important as some of the data plane operations. As you're doing different CI/CD operations, making sure that the different deployments can happen quickly, that you get great responses from ARM, really fast responses. We're looking really closely at reliability of ARM and the different operations, but also latency. As operations take a long time, how do we make sure that we can make sure that the P99s are great? And also making sure some of these limits and some of these impediments and that you're running into, how can we increase those limits and remove them? There's definitely limits that are causing challenges today. Today there's a limit on the number of deployments in a resource group. Once you hit 800, that's it. You cannot deploy again to that resource group until you start deleting some of the deployments. We're working on increasing those limits. There's a limit for 980 resource groups in a subscription, number 800 resource types in a resource group. So we're looking at expanding a lot of those. So a lot of energy from the team is focused on these. And then on the template side, we're continually looking at ways that we can improve the language and make the templates easier to write, easier to maintain, ways that we can make it easier to compose and depend on different things through some things that we talked at a build called modules. and different ways that you can preview things that could happen. What's the sort of what if? What's going to happen to the data plane of a resource if you do a deployment? Ways making those easier for you to understand. Improving all of the docs around those samples. And then some of the things that we want to do on resource management. The top requested user voice item on Azure Resource Manager's user voice is renaming the resource group. The resource group right now is sort of the URL for everything. So it's like renaming the keys of all resources across all of the different resource providers that also have the resource group name is a lot harder than it sounds. Making sure that we can improve the quality of resource moves so that you can move your resources from one subscription to another subscription or from one resource group to another resource group. Making sure that resources are taggable. A lot of our customers use tags to put on resources so that they can flow into their resources for billing scenarios. And today, different resources still don't support tags. They don't support the right constructs to support a tag or don't export them into billing. So this is where sort of my police officer job at Microsoft will continue. And then also making it easier so you can see what's changing in the APIs, what's changing in the logs. Today we have a slide with a bunch of resources and links on docs that we've written, but also the Swagger repo, if you haven't seen that, where you can learn about the new API changes, things that are in preview, things that are in GA. But how do we summarize those so that you really understand what's changed? What's this month's new set of APIs? When are those going to be in the SDKs? How do you start understanding what the impacts to your services are? And some of the ways that we're just trying to enable management ISVs to really expose their services in Azure. Sort of ARM is the single service that every team needs to interact with in some way, shape, or form to be able to bill into the customer's subscription. So if you're an ISV, getting into a managed app, getting into a marketplace, getting into a resource provider, improving the ways that you as customers can consume those things. And there is a cycle here because internally at Microsoft there is lots of usage of other services, and we use our own services to build other services, and sort of there's a tier of these where even you'll use these services and then expose other services to your customers through Service Catalog. So enabling those things is going to be continue to be a thing that we work on, and we'd love your feedback on existing managed apps and Service Catalog and ways that you can build your own enterprise catalogs. So some of the call to actions as we wrap up. There's no ARM booth, so if you're walking around looking for the ARM booth, make sure you look for this booth called Infrastructure as Code. We're in the Developer Tools section, right across from that big circle spinny thing. This is the ARM survey link, and I'll leave it open for a bit. It's just ak.ms ARM Ignite 2018. We have 3 $25 coupons for just the people in this room or anyone that fills it out in the next hour. So from 5:09 to 6:09. We'll pick 3 names, and then we'll email you, and then you have to come by the booth probably tomorrow since the booth is done at 6 today. But really leverage ARM templates for this journey to be declarative. Come and talk to us about what your challenges are, what you think you've solved, what do you think you want to share with the community. We definitely want to share these with others and make sure that you can influence other customers on this journey depending on where you're at in that journey. And then sign up for the Terraform OS SRP, as Simon mentioned. These are the related sessions. There's a couple that happened yesterday. The Arm Yourself for Success was yesterday earlier, and then there's the Security and Governance session. That was Joseph and Satya, where they gave an overview across all of policy, blueprints, and graph and management groups. Then there's a session tomorrow. A couple on Terraform. The tips and tricks is 4 o'clock. There's 2 at 4 o'clock that you'll have to choose which one resonates most with you. There's the tips and tricks that's really going to go into detail on templates and best practices on templates. Brian and Gaurav spent a lot of time helping customers with templates, internally with templates. Brian reviews pretty much every template that goes through the Azure Quick Start. So he's got lots of war stories and sort of ways that you can reduce, reuse, and recycle on templates. And then there's a deeper dive on blueprints and policy, graph, and management groups at 4 o'clock, also at 4 o'clock tomorrow afternoon. and then another Terraform session, and then the Azure Deployment Manager session Friday just after lunch. And then here's some of the reference links, and we have a demos link that just goes to a GitHub once you get the slides. Hopefully you've got the slides. We posted them earlier in the week. It goes to just a GitHub share where you can see them. But lots of links here to get to quick starts, if policy samples, different schemas, all of the new in-browser REST API experience to leverage Cloud Shell to play with different ARM templates you can check out. And this is a great time for questions. Definitely give us feedback on the session. This was sort of the 200 level, sort of all up ARM, sort of a little bit on all our new features and sort of what you can do to kind of get you from 0 to 60, and then sort of navigating the different infrastructures, code scenarios, and then yeah, tomorrow we've got lots of the deeper dives. Any questions? Go ahead. There's a mic there if you want to, or just yell it. I'll repeat it. For the question is in the subscription-based deployment, you had to specify the location where the deployment's happening. Will that be carried down to resource group as well? So in that case, because that in that case, Simon, you were doing a resource group. Can you enable the other mic too?
Sorry. So the example I showed, it basically just used the deployment function and grabbed the location property from that. So when you do a subscription deployment, we expose the location that the subscription deployment was executed and the metadata was stored in as a property on the deployment object. But when you deploy to a resource group, or indeed create a resource group, from within a subscription scope template, you can choose to do that wherever you like. There's no binding there. So does that answer the question? I don't know who answered the question. So who asked the question? Sorry. Okay.
You can stop.
Yeah, I mean, come up afterwards or stop by the booth tomorrow. We'll talk more.
We're around if you want to ask questions, but thank you very much for your time. Hopefully it was useful. Give us thank you.